Okay, so these are proofs. Now, right here, you always write what's given first. So given always goes first. So that was an easy one to fill in. You have AB is congruent to CD. And then the reasoning behind it is always given. Now, in this sheet that we filled out yesterday, we have what was given and what we can say about that. Well, here, whenever there's a congruency symbol and you use the definition of congruency, it drops that symbol. So sometimes, in certain scenarios that you'll see, we have to drop this symbol and just say equals to. So that's what they did here. So your reasoning, what that's called, is definition of congruency. If you want to shortcut that, you can just put definition of and the congruent symbol. What happened between B and C? Symmetric. They just swap places. So it's symmetric. In D, the definition of congruent segments is the same thing as this right here. These are the same thing. I just don't write segments. I say definition of congruency. So now they're telling you to do it again. So if we had it and we did that and it dropped it, now it's dropped and we're doing it again, so we have to bring it back. So now it's CD is congruent to AB. You are done. Hey, Cardell, tell me what time we get out of here. 1:28. Okay. 12:55. 1:28. Is that what you said? Is that what you said? 1:28. Okay. Okay. On this sheet, we're going to practice proofs some more. So what we're going to do is we're going to practice this together, a couple of these, and then you're going to do this on your own. But it's very important that you stay with me and pay attention to these two because these are the more difficult ones. So let's start. You always have your statement here and your reasons here. So here's your column. What always goes first? Given. So everything you're given, let's write it. How many things are we given? 3. So you can write HI equals 13. IJ equals 13. And IJ is congruent to JH. The reason behind that is given. So what it's told me is that HI is 13, IJ is 13, and IJ is congruent to JH. So what we have to prove is that since this is 13, so is this. So stay with me. I like number 2 a whole lot better than number 1. So first thing we have to do, you see how these have equal signs and this one has a congruency symbol? We have to drop that. What's it called when we drop it? Definition of congruency. So we're only going to write that one. We don't have to write these again because they already had an equal sign. So let's just write this. J is equal to JH. Okay. Now, isn't IJ equal to JH? That's true, right? What is IJ equal to? What's IJ equal to? You see how it's equal to 13? So instead of writing IJ, we can plug it in, which is by what? Substitution. Now we can say 13 is equal to JH. Well, it's now, you see how JH is equal to 13? And HI is equal to 13? Don't we want to show that HI and JH are the same? That's our goal. This is our goal right here. Is that HI is the same as JH. Well, are they? Yes. So now, either by substitution or what property, the fake one that cuts somebody out. Transitive, do you see how HI is equal to 13? 13 is equal to JH. So by the transitive property, we can cut out 13 and just say HI is equal to JH. However, there's one more step. What? Yeah, because look, we don't have a congruent symbol. Your goal tells you you have to have a congruent symbol. So, we have to add it back. HI is congruent to JH, which is, are you not going to write this down? Definition of congruency. Do you kind of see it? A little bit? Does it make a little bit of sense? Okay, here's the good news. 2.7 and 2.8 are the last lessons before our test. Your test is next Friday, which means we are taking over a week to cover 2 lessons. And we usually cover 2 lessons in like 3 days. So I'm taking a lot of time so that we can make sure we really understand this chapter, because it's pretty difficult. Okay, did y'all hear anybody complaining about their test they had to take today? Any of your friends have to take it? No? Some of them? What'd they say? Nothing? Oh. They're complaining about it. This isn't easy stuff. Okay, this isn't just algebra anymore. So we got to put our game face on and we got to step it up a little. So let's do 2. I like 2 a whole lot better. It's a lot easier to make sense. So write down what you're given. That's your first step. Colby, you writing this down? Do we have to go through the definition of congruency? Well, they didn't have a congruent symbol, and our answer is an equal sign, so we don't have to go through it. Okay, what is this called? This right here. A line what? Segment. Guys, almost 90% of the time when you see a line segment like this, you are going to use segment addition postulate. Almost every single time. So if you see a line segment, think to yourself, oh, I'm probably going to use segment addition postulate. However, you can only use segment addition postulate when you have 2 pieces. Like AL plus LS equals AS. Or block this one and use these last 2 pieces. So what we are going to have to do is we're going to have to use segment addition postulate. Because our goal is to prove that AS is equal to LK. So, can't I break down AS into 2 pieces equals this whole thing? So, A what plus what equals AS? Do y'all see this right here? I know Jacob's got it. But do y'all see how we could make this into segment addition postulate? AL plus what? LS equals AS. So let's write that down. AL plus LS equals AS. So we did just this piece. We only did AS. Now we need to do piece LK. So there's 2 pieces that make LK. What's the first piece? LS plus SK equals what? LK. Good. Do you see this right here? This is our goal. AS equals LK. Well, here's AS and LK. So we have to get these 2 to set them equal to each other. Our problem is we can't set them equal to each other because they're not the same. What do these 2 have in common? this one right here, right? They have LS in common. But AL and SK, those are different. But what do we know about AL? It's the same as SK, right? So, plug it in. Step 3. Instead of writing AL, let's write SK. Now I'm going to write it all over again, all of it, so you can see it. What property is that? Anytime you plug something in, it's substitution. Okay, so let me refresh you. Let me say this again. We use segment addition postulate twice because I wanted to show that AS, both of these pieces, are equal to LK. Our problem was we can't set them equal to each other until they're actually equal. LS was the same, but these two were different. But we used substitution to plug in SK. So now these two are the same. Is it okay that their order's backwards? It's okay. Still it's the same thing. Now, these are the same. So instead of writing this whole thing, we can write AS equals LK. Is that what we wanted? Was that our goal? Yes. Now, there's two ways. You could have either said substitution or what? Transitive. Either one of those properties would work here. Okay. We have 20 minutes to finish this. So the first 3, I just want you to tell me the property that goes with it. So we're going to take it a step at a time.